So ionic compounds. Ionic compounds are really common. Most of the material of the Earth's crust would qualify as ionic compounds. These compounds are very stable because the bonds that hold them together are extremely strong. And here are just some examples. Morton's light salt, that's a mixture of two different ionic compounds, sodium chloride and potassium chloride. Calcium carbonate is the active ingredient in Tums. And so both of these are things that you would consume, right? So some ionic compounds you can eat. As with everything, though, everything is toxic at a certain level, right? Even oxygen and water, necessary for life, but too much will kill you, right? And so even though these can be ingested, they have to be ingested in reasonable quantities, right? Here are two minerals, ionic compounds, and sometimes these are found like in caves and stuff with these beautiful crystalline structures. This is just another form of calcium carbonate. I wouldn't recommend swallowing that if you have heartburn because it's not going to do much for you. And this is a type of mineral called trona, and it's got this really kind of long and awkward formula. Yes?
It's funny you mentioned like having too much water. Somebody, like in the news recently, somebody just died of water toxicity.
Yeah, there've been several things like that. Often it's been a contest, you know, to drink so much water and win a PlayStation or something. Not a good idea. What happens is you get too much water in your body and you dilute all the electrolytes in your body, and then your body can't function anymore and you die. So, yeah. You know, we think a lot about, toxic chemicals. Everything is a chemical. Anything that you could hold or touch is a chemical, right? The air we breathe is chemicals. They are all harmful in some quantity, but many of them are beneficial and necessary in other quantities. And so it's not about whether it's toxic or not, it's about how much do you have. And that's one of those things that I wish every person in the world could understand, because we could stop freaking out about some things then. Okay, we're going to learn how to write the formulas for ionic compounds. These are the basic steps. We need to start with the symbol for the metal cation with its charge, and then we're going to write the symbol for the nonmetal anion with its charge. And write those down, and then we're going to look at them and adjust the subscripts so that we can get them to balance charge, meaning we need the total positive charge and total negative charge to add up to 0. And then we should always double check that we did it correctly. So summarizing ionic compounds. Ionic compounds always contain positive and negative ions. The first element is usually a metal. This is the one exception that you are expected to remember in Chem 1A. If it starts with NH4, NH4 is unusual in that it's a polyatomic cation. In the chemical formula, the charges have to add up to 0, and the formula for ionic compounds is always going to be an empirical formula. It's the lowest ratio of the ions. So let's practice writing some formulas. So potassium. Well, what's the element symbol for potassium? K. Okay. And what charge does a potassium ion have? +1. Why? How do we know that? It's in group 1. All of the elements in group 1 are going to form +1. Isn't that nice? So this is K+. And the symbol for sulfur is S. And what charge does a sulfur ion have? 2-. So if we start at the noble gases and call that row 0, and then we count backwards, -1, -2, that's how we can know that sulfur is -2. Now we have to figure out what the subscript should be in this formula so that the compound is neutral. There are different ways of thinking about this. You may have heard of a crisscross method where you crisscross the charges, they become the superscripts. This is a method I prefer. I'm just going to kind of look at this and think about it. So I'm just going to add up here. It's kind of silly, but I'm just going to add up the total positive and negative charge. Is that going to add up to 0? No. I can't take anything away, but I can add stuff. What should I add to help those to be equal? Well, I'm just actually going to draw one. I'm going to do the subscripts in a minute. Yeah, we are going to use subscripts, but so if I had 2 potassium ions, then the charge from them would be +2, and the charge from the sulfur is -2. And so that group of ions together would be neutral. That's the lowest ratio. And so I need 2 potassium ions, so that's K with a subscript 2, and 1 sulfur, S. Okay? Let's do another one. Aluminum and nitrogen. So aluminum is Al. What's his charge? +3. So group 1A metals, +1, group 2A metals, +2, group 3A metals, +3. And nitrogen is N, and what's the charge on nitrogen? -3. So this is a place where you could get in trouble if you're crisscrossing. I'm going to look at that and say, well, I've got positive and 3 and -3. I just need to shove them together, and it'll be neutral. And so the formula for this one is AlN. It is important that your capital letters be capital letters, not just large, oversized lowercase letters. You know. But that's a capital A. No, it isn't. That's a lowercase a. You just made it really big. And if you want to do that when you're doing all the rest of your writing in chemistry, go for it. It's kind of cute, go whatever. If you're a person that likes to write in all caps, okay, this L has to be a lowercase l. Because if it's a capital, then it can become some other thing entirely. So we need to have the correct forms of these letters. That is too skinny. Okay, any questions? So that's how to write formulas. How do we name them? So some compounds do have common names. An example would be table salt, sodium chloride. But it also has a systematic name. And these systems that we came up with were not intended to torture intro chem or gen chem students. They actually worked really, really hard to make them as simple and intuitive as possible. I totally get, doesn't seem that way when you first start learning them. But I challenge you to come up with a simpler way to name these compounds. We definitely don't want to call them George and Steve and Sally, because then you just have to flat out memorize what those formulas are. And here the names are going to tell us what the formulas are. The formulas are going to tell us what the names are. So identifying the type of compound is the first step. So we're talking about ionic compounds. So if we see a metal as the first element, it's ionic. That's all you need to know. So examples here, NaBr, sodium's a metal, aluminum's a metal, calcium's a metal, magnesium is a metal. Doesn't matter what the rest of it is. Okay? So these are the rules for ionic compounds. And the cations, the metal cations are, the book likes to break them into 2 different groups. So the ones we've talked about in group 1A, 2A, and 3A, they have one type of ion, and the charge is predictable from the periodic table. The transition elements, all of those guys in the middle, most of them will make 2, 3, 4, even 5 differently charged ions. So then we have to add a little something to their names. So the simple ones is group 1A, 2A, and 3A. They always have the same charge. So their names are the same as their element names. So an aluminum ion is aluminum with a 3+ charge, because aluminum is in the third row column. Now you notice that there's some extras shown here. There's zinc and silver. And those are also, they only make one ion, and so their names are just zinc and silver. Scandium is also one of those, but you don't need to take up space in your brain remembering scandium, because you're not going to need it in this class. So all of the other metals can form more than one kind of cation. So here are some examples. Chromium can make two different ions. One's +2, one's +3. Copper could be +1 or +2. Lead could be +2 or +4. You can't tell just looking at the periodic table what those charges would possibly be or what it is in the compound. So these guys have their element name followed by a Roman numeral. So if we think of Henry, King Henry of England, right? There were at least 8 King Henrys, right? There's Henry I, Henry II, Henry VIII, etc. And we indicate who they are by the Roman numeral after their name. Because if you call the palace and ask for Henry, well, do you mean Henry III or Henry IV? Right? It'd be confusing. So, have to have individual names. So that's what we do here. Except this has nothing to do with who's older or younger. The Roman numeral flat out tells us what the charge is. So this is chromium 3, 3+ charge. Here's tin 4, 4+ charge. They're Roman numerals. We don't want them to get confused with subscripts or something else. I think that's maybe why they used Roman numerals. So let's just review Roman numerals. So the number 1 is a capital I, and the number 2 is 2 capital I's, and the number 3 is 3 capital I's, and you're like, well, they're just doing tally marks. No, 5 is a capital V. I don't know why they picked that. Doesn't matter. 4 is 1 before 5. So it's an I, 1 before 5. And 6 is 1 after. So that's VI. And it goes on like that. And that's as far as we really need to go. We get up to 10, 10's an X, and beyond that I don't remember. There's L's and M's and all kinds of other letters that represent hundreds and thousands and stuff. Okay. So the element name followed by the Roman numeral with its chart indicating the charge. This is an older system of naming where they changed the ending of the element's name and they used the Latin names for these. So iron could be ferrous or ferric. You may come across these possibly in a homework problem, hopefully not a worksheet, but it might show up somewhere. So you don't need to freak out. Just go look it up. It won't be on exams. You should know that older system exists. When I was a kid, they were always advertising, crust with stannous fluoride. Well, stannous is tin, right? It's tin 2+ ion. I don't want tin in my toothpaste. I think that's why they chose to use stannous instead, because people don't recognize that as tin. It's part of a compound. Its properties have changed dramatically. You're not chewing on tin foil.
How did they determine which ending?
That's a great question. How do they determine which ending? So there's a pattern here. The us is the lower number, and the ik is the higher number, but it doesn't tell you what the number is.
What if there's more than
That's a great question. I don't know. Because like manganese can be like 1, 2, 3, 4, 5, 6, or 7. I don't know what the old system was. If I remember that, which I won't, I'll look it up. Because that's a great question. That's a great question. So how are you supposed to remember all of this stuff? So this slide is a summary of my tricks. Okay? So metals in group 1A and 2A form ions with the same charge as the group number. And then metals in this triangle are also predictable. So here we have aluminum. Aluminum is in group 3A, positive 3 charge. And then here is like going down the stairs, 3, 2, 1. So we've got positive 3, positive 2, positive 1. These guys are also predictable. Cadmium would be +2, gallium and indium would be +3. I don't expect you to remember those guys. So what I'm going to say is groups 1A, 2A, 3A, zinc, and silver. Do not use Roman numerals. Because if you call my house and ask for my husband, you're not going to say, "Can I speak with Kirk the First?" Right? There's only one. We don't need to have numbers designating which one. Now, if you've got a junior and a senior in the house, then you have to specify, right? But you don't do it unless you have to. We don't have to with these guys. There's only one. Okay? Groups 1A, 2A, 3A, zinc and silver do not use Roman numerals. Let's make this another color. All other metals need Roman numerals. Okay? Groups 1A, 2A, 3A, zinc and silver. That's what you got to remember. So those were the cations, the anions. We can have monoatomic anions, so those have one atom. And these are named by changing the ending of the element name. So these are the nonmetals, fluorine, chlorine, bromine, these guys. And their charges are predictable from the periodic table, and we change the ending of the name. So chlorine becomes, chlorine becomes chloride. Oxygen becomes oxide. Now, if you got confused and you wrote oxygenide, I wouldn't mark you wrong. I might giggle, right? But I wouldn't say you're wrong. So some of them, leave out more than just the last couple of letters. So this is how I think about ionic compounds. With ionic compounds, you have to have a positive and a negative. The metals I think of as being masculine, and the nonmetals would be non-masculine or feminine. And so you've got a guy and a girl, and when they form a compound, they get married. This is just part of Mrs. K's chemistry land, a very strange place. If you get a formal wedding invitation, or you're sending out wedding invitations, they're going to be addressed Mr. and Mrs. Mr. always goes first. Why? It's not oppression and patriarchy. We're not going to get into that. It's just what it is. It's what we decided to do, and everybody does it the same way. So in the ionic compounds, the metals are the Mr. The metal always goes first. And the nonmetals are the Mrs. She always goes second. And traditionally, who changes their last name when they get married? The woman does. And we're not debating whether that's right or wrong or anything like that. This is just like old, back when I was a kid. So when Fluorine gets married, she changes the ending. She only has the one name, but she changes the end of it, like her last name. Okay? And this indicates that she's part of a compound now. Okay? It changes when I don't want it to, and then it won't change when I want it to. So we can talk about binary compounds. Binary means two. And so these are the simplest ionic compounds. They just got two elements, a metal and a nonmetal. And when we name the compound, We name the cation, that's the mister, and then we name the anion, the missus. For the space in between, these are not proper nouns. You do not capitalize them unless they're at the beginning of the sentence. So KCl. Well, the first element is potassium, right? Does potassium need a Roman numeral?
No.
No, because it's in group 1. If it's in group 1A, 2A, 3A, zinc or silver, no Roman numerals. So that's just potassium. And then chlorine changes the ending of her name and becomes chloride, potassium chloride. Okay? CaO, well, the Ca is calcium. Calcium's in group 2. Groups 1A, 2A, 3A, zinc, and silver. I'm going to say that so many times today that you can't help but remember it. Groups 1A, 2A, 3A, zinc, and silver. So this is calcium. And then O is oxygen. Change the ending of the name, calcium oxide. Okay? It can be a little tricky when you're first doing it, but can you see that the basis of it is actually quite simple? We're not trying to trick you here. There are other places that just flat out are really tricky. So let's practice. Name the compound Ag3N. Well, Ag stands for silver. So silver, does it need a Roman numeral?
No.
No, because it's in groups 1A, 2A, 3A, zinc. It's silver, right? No Roman numeral. Okay, so that's it, just silver. And the N, nitride. So silver nitride. What about the 3? We don't need to do anything about the 3 because the charges, silver is always +1, nitrogen is always 3-, and looking at these guys, oh, I need 3 of these to make them equal and be neutral. So I don't have to say, I don't want to say trisilver nitride. It's not necessary. We don't want to write extra stuff. We're just writing what's absolutely necessary.
What if there's like a 2 or something in front of the silver, like it's, or the nitrate?
Well, like if there was a 2 after the nitrogen,
Yeah.
again, with ionic compounds, you don't have to say anything about those subscripts. Yeah. Because silver and nitride are the names of the ions, and we know what their charges are. So that's what tells us how to put them together. So what would the formula be for rubidium sulfide? RB and S. And you're correct, it is RBS, but let's make sure. What's the charge on rubidium?
1.
Yes, I blanked out and thought it was 2. Yeah, it's not right. And this is 2-. Right? So, again, this is what I'm thinking in my head. I've tried all kinds of different analogies. And this is the simplest one. Just making pictures, right? It's like, well, how can I have the charges be the same? Well, I'm just going to draw another one of those. And we're not going to make it about math or anything, lowest common multiples or anything like that. So then this is RB2, because there are 2 RBs, S. Okay? What about those other metals that do need Roman numerals? Well, it's the same idea here. It's the name of the metal and the name of the anion, right? It's just that now the name of the metal has a Roman numeral in there. Okay, so CrBr3. Cr represents which element? Chromium. And then before you go any further, you ask yourself, is it in groups 1A, 2A, 3A, zinc, or silver? No. What does that mean? It needs a Roman numeral. So I'm just going to put the parentheses there. I don't know what it is yet, but I put the parentheses and then I'll remember, oh, I need to go back and find that. And then Br, bromide, right? Bromine becomes bromide. Okay, now we can figure out what that Roman numeral is. We have to look at the charge on the other ion, the anion, and the ratio of them and figure it out, right? And some of you can just look at it and tell, and others of you can't. So if you can't, this is what you should do. So I'm going to write, there's one Cr in this formula, right? So I'm going to write Cr once, and there's 3 bromines. So I'm going to write Br 3 times. We know what the charge on bromine is because of the periodic table. They're each -1. So that brings my negative total to -3, which means my positive total has to be what? +3. There's only the 1 chromium, so all of this charge has to be on the 1 chromium. So what's the Roman numeral? 3. Master in Chemistry cares, and actually the worksheet will also care, that that is a capital I and not a lowercase l or a 1. Even if it looks right on the screen, the computer will be upset.
A capital I?
Capital I. Roman numerals are capital I's and capital V's, plus some other things. Okay, here we have a compound FeS. Let's name that. Fe stands for iron. Does iron need a Roman numeral? Yes, because it is not in groups 1A, 2A, 3A, zinc or silver.
I'm going to dream about this. I'm going to dream about this.
Yeah, you will. Sulfur becomes sulfide. And then we have to figure out what the Roman numeral is. So right now I'm drawing on the screen, and when you start out you may need to draw this on your paper, but then later you can draw it on the whiteboard in your mind, right? You can just kind of see it floating in the air. There's 1 iron and 1 sulfur. What's the charge on the sulfur ion? 2 minus. So what does the iron have to be? 2 plus. Because the total of the negative charge has to be equal to the total of the positive charge, so they add up to 0. So then this is iron 2 sulfide. Right, the formula for ruthenium 4 oxide. That's a symbol for ruthenium. Are you? Are you sure? And what's the charge on that?
We don't know. Oh, 4.
4. Sometimes students, get things a little mixed up, and that they think that's how many of them there are. No, it's the charge. It's just the charge. So that's ruthenium 4. And maybe you don't really remember what symbol ruthenium is. A good guess would be the first 2 letters, right? Of course, that's not going to work for rubidium, but you figure it out eventually. Okay, oxide, that's oxygen, and what's the charge on oxygen? 2 negative. Can you see what I need? I need 2 oxygens, right? For those of you that are not seeing that, so I've got +4 and -2. I need more negatives. So I'm going to write in another O2 minus, and that's going to give me -4 + 4, -4. It's all good. So this is RuO2. I think the compound RuOK would be fun, but it just doesn't exist. Questions? if we're naming ionic compounds that have polyatomic ions, the pattern is the same. You name the cation and you name the anion. What's different here is that the anion has more than one element in it, and it has a name that involves memorizing, which is why I put these on the material to memorize for that memorization quiz. Names and formulas of polyatomic ions must be memorized. So if we look at NaNO2, again, only 2 ions. So the Na is the first one. That's sodium. Doesn't need a Roman numeral because it's in groups 1A, 2A, 3A, zinc or silver. And then everything else is NO2. So NO has a positive charge. The rest of it is NO2. We don't necessarily have to know the charge on that to get its name, but the way you would figure that out is, well, if this one's +1, this one has to be -1. And so Na plus is sodium, and NO2 minus is nitrite. So sodium nitrite. It's nitrite because that's what they decided to call it. So this list of polyatomic ions should look familiar because this is pretty much what was on that list for you to memorize. Now, some of these get used a lot more than others. And so I would say nitrate, phosphate, chlorate, sulfate, ammonium, hydroxide, carbonate, and acetate. If you memorize those, you'll do pretty well. Yeah.
Can you cover why they form ions, like why they form?
We don't really specifically talk in Chem 1A about why they form ions like that, but when we talk about Lewis structures, we will do Lewis structures of ions like sulfite, and you'll see that they need the extra two electrons for everybody to get their octet satisfied.
There's like no like reason, there's no like rule for how it's formed?
No,
No.
there's no real specific rule.
Um,
All of chemistry really is us observing nature and looking for patterns, right? And so here we can find patterns and then we can come up with explanations, but there's not really a rule. Yeah. So most of those polyatomic anions are what are called oxyanines because they have oxygen in them, and they're anions. So they're oxyanions. And there are groups of them. Let's go back here real quick. So here, there's chromate and dichromate. There's chlorite and chlorate, and perchlorate and hypochlorite. And you look at those guys, and they're all chlorine and oxygen. There is a pattern you can memorize so that if you know what chlorate is, you can figure all the others out. So that cuts down the things you have to memorize. So when there are two ions in the series, the one that has more oxygen atoms ends in 8, and the one with fewer ends in 8. So here we've got NO3 minus and NO2 minus. The only thing that's different is the number of nitrogens. The charge is the same, the number of nitrogens is the same, it's just the number of oxygens. So this one is 3, that's nitrate, that's like the regular one, and this is the light version, nitrite. It has one less oxygen. Sulfate, sulfite. So the ite does not mean 2 oxygens. It means one less than the 8. So sulfate has 4 oxygens. So sulfite has 3 oxygens. Charge stays the same, thank goodness. If there's more than 2, then we throw in some prefixes. hang on just a minute. Yeah. So perchlorate, per means more. So the chlorate is the one you memorize, ClO3 minus. Perchlorate tells me it has one more oxygen. Chlorite, less oxygen. Because, Bud Light has a third fewer calories than regular Bud. Well, chlorite has a third fewer oxygens than regular chlorate. And then hypo is a prefix that means below, so this is even one less. The oxyanions with bromine were not in that list, and the ones with iodine are not in that list. But these guys are halogens. Fluorine, chlorine, bromine, and iodine, they are in the same family, and so they have a lot of things in common. They do things a similar way. So bromate is also BrO3 minus, chlorate, ClO3 minus. So I think of them as being like sisters, and they act the same in many ways. So what would iodate be? It's not right with the highlighter. It's going to follow the same pattern as the I instead of Br or ClO3 minus. Same number of oxygens, same charge. So if you memorize chlorate and the pattern, you can write the names and formulas for all 12 of these. So this is another kind of summary slide. So what I recommend doing is memorizing the 8s and the pattern. Only the number of oxygen changes, the number of charge or the other ion doesn't change. So here's the one you memorize, the chlorate. This is hyper, it's got more. This is the light version, it has less, and the hypo is below that even. Okay, and just a note that this is upside down of what it shows you in your book, because it makes more sense to me to have more oxygens at the top and fewer at the bottom. But it's all the same. Any questions? So let's name the compound SnClO3 Well, what's up with the parentheses here? There's two of what's in the parentheses. Okay? The book just kind of ran into that without really explaining it. But to name this, we name the first element, the metal, and then we name what's left. So Sn is which element? Doesn't start with an S. Tin. It's Sn from stannum. So tin, does tin need a Roman numeral?
No.
Is it in groups 1A, 2A, 3A, zinc or silver? It's in group 4A. That's not 3A. It needs a Roman numeral. And then we're going to look at what's inside the parentheses, ClO3, and what's the name of that? Chlorate, because I told you that's what it was. So this is tin something chlorate. We have to figure out the Roman numeral. So I have one tin ion and I have 2 chlorate ions. I think of those parentheses as being a little bit like shrink wrap. You go to Costco and you can't just buy one bottle of ketchup. You either have to buy like 2 or 3 bottles of ketchup, or it comes with the mustard and the relish and everything else, and it's all shrink wrapped together, right? You have to buy the whole package. So this is a package deal, and the parentheses are like the shrink wrap, and how many of them is on the outside. Because if we wrote it this way, if we didn't use the parentheses, that would be confusing. because that sure looks like 1 tin, 1 chlorine, and 32 oxygens. So we don't want to do that. So that's what the parentheses are for. You only use them for polyatomic ions. If you have something like chloride, Cl, you don't need to shrink wrap the single item. It's only when you've got multiples. Okay? It's not good to waste plastic, right? It's bad for the environment. Okay, to find the charge on the tin, we do need to know what the charge on the chloride is. It's -1. So if I've got 2 of those, that's what the formula says. I have a total of -2 charge. That means I must have +2 charge. And there's only one of these. It's got to have all the +2 charge. And so this is tin 2 chloride. Write the formula for cobalt 2 phosphate. It's going the other direction. What's the symbol for cobalt? CO. That's a capital C and a lowercase o. Because if the O's too big, now it's carbon monoxide. Right? It's not. So cobalt, and what's the charge on the cobalt ion? 2. Because, it's cobalt the second. It's got a +2 charge. What's the formula for phosphate ion? PO4 -3. So even if you went through and memorized and just killed the memorization quiz, you might have already forgotten some of them. Or maybe you just, guessed lucky or something on the quiz. What you want to do here is you want to try to write the formula for phosphate just using your brain. And then check it with a list or the internet or something to make sure that it's correct. If you always look it up, you're not going to remember it. So that's the charge. And so now we have to figure out how many of each. Well, let's just look at our totals here. I have +2 on one side and -3 on the other side. So I need more positive charges. The only thing I can do is write another CO2+. So that makes this +4, and now the other side's -3. So now we're out of whack the other way. So PO4, 3-, and this becomes -6. This is where you think, this is never going to come out right. Hang on. Let's add another one of these. We're going back and forth and back and forth. Oh, there we go. +6 and -6. Now some of you can look at that and say, well, 6 is the common multiple of 2 and 3. Great. You do your stuff. A lot of people can't see that. This is one of the reasons I like kind of drawing it this way. It really helps you to understand, oh, I've got different numbers of these ions and they go together, instead of just having a trick where you crisscross numbers. So then the formula, CO, I've got 3 of them. PO4 is a polyatomic ion. It's a group. It's a bundle pack. So I have to put parentheses around the outside, and then I'm going to put a 2 because there's 2 of them. Any questions?